All right, ladies and gentlemen, today we're talking about Bayes' theorem on worksheet number 11. And Bayes' theorem tells us about the relationship between a conditional and its inverse. And what I want you to see, what I have highlighted there is Bayes' theorem, the actual formula, but don't worry, we don't actually have to know this formula. But I wanted to note that you see that I have some C's highlighted up there. And just notationally, what I want you to remember is that those C's imply complement. Okay, it's the opposite. Example, if I tell you that 40% of students eat lunch, then I'm also telling you it's complement. Without saying the words, I'm also telling you that 60% of students don't eat lunch. Hopefully that's not true. So here's what I want us to look at. We can do this Bayes' theorem by using a tree diagram. So if we look at this first formula, it says that an employer is looking to fill some positions and several college students are interviewed. From past experience, we know that the employer, so let's look at blue, will offer second interviews to 65% of the college grads. Well, right there is our 65% is offered a second interview. The complement of that is that if I tell you 65% are offered a second interview, I am also telling you that 35% is not offered that second interview. So it isn't written down, but you do have to understand that I'm also giving you the complement when I give you some information. So looking at that next one, it says of the college grads offered second interviews. So now we're only looking at the people who were offered second interviews. Of the college grads offered second interviews, 70% of them were hired. So from the people offered second interviews, I branched that tree diagram out a little bit more, and it says 70% is hired. That also means that 30% is not. There's the complement again. Next line, it says only 5% of the college grads not offered second interviews. So they were not offered second interviews and only 5% were hired. That means that of those not offered second interviews, 95% was not hired. So now we have our trees written out. And what you need to understand about the trees is it does set up our conditionals because we're looking at certain groups of people. Of those offered second interviews, we have new probabilities. Of those not offered second interviews, we have new probabilities. So looking at our questions, it says, what's the probability of getting offered a second interview and not getting hired? Well, and means multiply. So as we go through our tree diagram, it says, what's the probability of getting offered a second interview and not getting hired? So I follow my tree, 0.65 times 0.3. Second question, what's the probability of getting hired and not being offered a second interview? Well, what we need to look at, the way that we have it written first, my tree diagram doesn't start with hired. It starts with either being offered the second or not offered the second. So what you also need to remember is that multiplication can be done in any order. So I flip-flop it. Let's put second, not offered second first and hired second. So if I follow that line, not offered second interview and hired, I have 0.35 times 0.05, which gets me out 0.0175. Looking at this next line, it says, what's the probability that they are hired? They do not tell me whether they care about whether they were or were not offered that second interview. All they care about is, were they hired? So what we need to look at this point is that, guys, there are two ways for me to be hired. There is the way that I had a second interview and I was hired, but there's also another way where I did not have a second interview and was hired. So I have to set this up as a double situation. I was either offered the second interview and hired, or means add, I was not offered the second interview and was hired. So I have to do both. I have to follow both lines. So I have my 0.65 times 0.7 plus my 0.35 times 0.05. And what this represents is our probability of just being hired. Question number 4 says, what's the probability of getting hired? Oh, there's a word we haven't seen in a couple days, given that a second interview was granted. So I have my given situation set up again. With that given situation, I have to set up my, remember givens limit my sample space. So I have to set up my conditional formula. My conditional formula is the and divided by the given. So I'm looking at the probability of being hired and having a second interview divided by the probability of having a second interview. Well, the probability of being hired and having a second interview, we actually just did in the prior problem, my 0.455. And the probability of having a second interview is that original, look up at your tree, the original 65%. So when I do that division, I get out 0.7. Now what I want you guys to look at is look up at your tree. Remember, given limits your sample space. In this situation, we were given that a second interview was granted. I am only allowed, based on how conditional probability works, guys, I am only allowed to look at this group of people because I am guaranteed that they were on that top line. It was given that they had a second interview. I'm not looking at any of the people in any other parts of the tree. I knew they had that second interview. So I'm only allowed to look at that group of people. So the math that we did 0.455 divided by 0.65 because we set up our conditional formula proves what our tree diagram is saying. Our tree diagram has those built-in given probabilities right within it because of how it's written. Okay, so it's not a coincidence that those answers match. Now, flip-flopping who we're looking at, question 5 says, what's the probability of having a second interview given someone was hired? Well, now we're looking at all of the people who were hired. We're only looking at the people who were hired, which is different than question 4, which was saying we're looking at the people who had a second interview. Different group of people. So we set up our conditional probability. What's the probability that they had a second interview given they were hired? So it's the second and hired divided by the probability that they were hired. Well, remember there were 2 ways to get hired. So look at question number 3. Question number 3, we had the probability of being hired, and that came out to be 0.4725. And question 5, second and hired, we've done that now a couple times. That was our 0.455. And this ends up being 0.963. 96% of the people who were hired, so we're only looking at the hired people, they were given a second interview. All right, let's take a look at the second question. 3 movies are showing at the theater. Teenage Vampire Angst, which I'm going to write as TV. Strip Mall Dog Rangers. Sounds riveting. I'm going to make that known as that is SM. And Kill Hard 4. Not a movie I don't think I would like to see. Not a movie I would like to see. All right, so we're looking at 60 tickets. Out of the first 60 tickets, 20 were for Kill Hard 4. So if you look down at my tree diagram, I have 20 out of the 60, which reduces to 1/3. And if you would prefer to work with decimals, that would be 0.33, repeating. 1/3 of them went to Kill Hard. It next said in our information that 30 were for teenage vampire. So I wrote that in my tree, that 30 out of the 60, which reduces to 1/2 or 0.5, went to teenage vampire. And the last 10, so 10 out of 60, 1/6 or 0.167 went to strip mall dog rangers. From there, it gives us some more information. Surveys have shown that 3/4 of kill hard viewers, so now I'm only looking at the kill hard line, that 3/4 of the kill hard viewers were male. So from kill hard, I said 75% were male, which is also implying then that 25% was female. Next line, it said 2/3 of teen vampire viewers are female. Well, that means that teenage vampire 2/3 are female, but that also means that 1/3 is male. And half of the dog rangers are female. So that means half are male and half are female. So now we can go ahead and we can look at our questions. It says, what's the probability that the ticket holder is a male who also saw a teenage vampire? So if I look through this, I want male and teenage vampire. I can flip-flop that around because in my tree, I start with the movie. So I want teenage vampire and male. So I'm kind of following that line. That would be 1/3. I think I did, 1/2. I was looking at the wrong question here, guys. 1/2 saw teenage vampire, and 1/3 of those people were male. So 1/2 times 1/3 comes out to be 1/6 or 0.167. Number 7, what's the probability that the ticket holder is female who also saw kill hard? So we're looking at female and kill hard. Flip-flop that around, kill hard and female. So I have it kill hard and female. 1/3 times 1/4 comes out to be 1/12 or 0.083. What is the probability that the ticket holder is female? Well, we can be female and have seen kill hard. We can be female and have seen teen vampire. And we can be female and also saw strip mall dog rangers. So we have 3 scenarios: kill hard and female, or means add, teen vampire and female, or strip mall and female. So we have to actually follow 3 lines. My kill hard, 1/3, and female, 1/4. Or my teenage vampire, 1/2 times female, 2/3. Or my strip mall, 1/6, and female, 1/2. And when you add all of that together, when you do that multiplication, it comes out to be 1/2. So number 9, last question that I'm going to do with you guys. It says, what is the probability if the ticket holder is female? That's another way to say given. So we are saying given that they are female. What is the probability if the ticket holder is female, given the ticket holder is female, that she saw kill hard? Well, now we're only allowed to look at the females. So setting up our conditional probability formula, it is the probability of kill hard and female divided by the probability of female. Well, gratefully, this is question number 8. So we already knew that answer. And let's look at kill hard and female. Kill hard and female comes out to be 1/3 times 1/4, which is where I'm getting the 1/12 from. So I have 1/12 divided by 1/2 gives us 1/6 or 0.167. So I'm going to do, or I just did those 2 questions with you guys. If you continue flipping, there are 2 questions for you to do your tree diagram on, and that will be your homework.